Let's talk about yield. In many areas, yield dominates manufacturing economics. Yield is what differentiates an announced product from one that you can actually buy at a reasonable price. If you're aware of manufacturing yield as a concept, odds are it's because you've been interested in semiconductor manufacturing. Anyone can buy the best semiconductor fab equipment, but only a small number of fabs can provide acceptable yield for cutting-edge processors. A lot of fabs can produce a wafer or two of cutting-edge chips with one or two chips that actually work, but that may be too slow or too hot. Yield is why you saw a Mac Mini using the Apple Silicon chips when they were first announced. Being a desktop machine, a Mac Mini could afford to run a bit hotter and use a bit more power than a laptop. Instead of throwing those chips away because they were unsuitable for laptops, Apple decided to recover at least some of the costs of climbing up the yield curve with their processors. An important factor in Pat Gelsinger's plan to restore Intel to its past glory is to use Intel's processor designs as pioneers in Intel's fabs. The idea is that Intel's fab operations will learn based on climbing the yield curve for in-house chip designs and then sell that expertise to outside customers. On paper, this is a plausible strategy, assuming that the goal of being both a designer and manufacturer is still a viable business model in leading-edge CPUs. It's pretty clear that there's no going back to Intel's dominance of both design and fab operations without outside customers for the fabs. The pragmatics are that Intel hoovered up what will amount to perhaps tens of billions of dollars of government support for US-based fab technologies and operations. If the government is okay with that, presumably they'd be okay with a chip vendor dominating a widely used CPU architecture, as well as being a first-tier fab operator. Another area where yield matters a great deal is electric vehicle battery packs. This is currently a headache for Tesla. Cybertruck and Tesla Semi were planned for using larger battery cells, which currently haven't achieved sufficient yield for these purposes. Unlike CPUs, where pricing and margins can be a bit flexible to accommodate initial low yields, EV batteries get launched into a highly competitive market where end customers of EVs have no reason to consider the yield curve on battery manufacturing. One more internal problem at Tesla to keep an eye on.